Hello, my name is Gilles Dubreuil, and I'm part of a group of Red Hat engineers helping with OpenShift migrations, and more specifically providing tools to assist with migration from OpenShift Container Platform 3 to OCP 4, which is in version 4.1 at the moment as a general availability. So as a source cluster, OCP 3 from version 3.7 to 3.11 are supported, and I am going to present you the CPMA tool, which is an assistant for migrating OCP 3 control plane to OCP 4. So let's get started. And first of all, we are going to retrieve the tool from its GitHub repo. I'm going to clone it locally here, and then we're going to build the program itself, which is a Go executable. So if we just run the make command, then we can build CPMA tool, and once we have that, we can execute it. So initially there is no configuration, so the tool is going to help us create the initial configuration file unless we provide command line options. And also environment variable can be provided instead of command line parameters. But we're going to use the tool to prompt us for those various information. So since we don't have any configuration file, the tool asks us if we want to save it for future use. We say yes. And then we are getting asked if we want to work in remote mode or local mode. The remote mode allows the tool to retrieve the various configuration files it requires from the cluster, and it uses SSH to do that. Of course, the SSH user needs to have the right credential, and more likely, if we don't use the administrator user by default, it will be a user which has sudo permission. If that's not possible, then the file can be retrieved separately from the tool and be stored locally, where CPMA will be able to pass the file from the disk. So here we go in remote mode, and then also the configuration files have a default path, which is here the default values are the equivalent of the OCP3, which is vanilla installation. Since the OCP version I'm using here don't have any path change, we can use the default. There's the one for CRIO, the one for etcd, master config file, and the node config file, and finally for the registries. The next is about the cluster context. So this could be prompted, or the tool can use kubeconfig to identify the cluster endpoint from the context. Here I have several clusters in my kubeconfig file, so I'm going to select the one we're going to work with, and then we're going to point to the master node. And finally, we need to provide the user that is going to be used for the SSH with the default port 22, and we need to provide the SSH key that is matching that user. Next is the working directory, where the CPMA is going to store the manifest file is going to generate. It's also used that for the configuration file caching, and this is where the file needs to be copied if we are in local mode. So I'm going to use just data and then the tool just gets started. So I'm going to interrupt the tool at this stage just to show that the tool has created the config file for the parameters we entered. This file can be modified at this stage and the tool can be rerun. The file is expected to be in either the home directory or the current directory. So if I rerun the tool, since the file is there, the tool uses the file and starts fetching the configuration file from the source cluster and also connects to the Kubernetes and OpenShift APIs to retrieve various resources. So you can generate the report and the custom resource manifest files. We can now see in the data directory, which is the working directory we mentioned, that there is one subfolder called manifest that contains all the custom resources that have been generated as manifest YAM files. And those files can be used in OCP4 as a day 2 operation to recreate those various resources. So we can, for instance, check the OAuth resource, which contains the only HT password identity provider, which is default. Not change that on the source cluster, so there's only one identity provider here. You can also check the cluster resource quota that we're going to use a bit later. That's another example of manifest file generated by CPMA. The next folder is master-0, which is the fully qualified domain name corresponding to the master node of the OCP3 cluster we're using here. And we can see in the subfolder that all the different configuration files have been retrieved and stored there. So when using the tool in local mode, this is where the file is expected to be, following the same structure. And finally, we have the report JSON, which is the output that the tool generates for the reporting of all the objects he has treated and all the various resources he has found. So we can check that as well. This is quite a long file. And so every time a parameter has been found on the CP3, has been treated, then it will indicate that that variable, or parameter so to speak, is be fully supported. And in some cases, there's parameters that cannot be ported across from OCP3 to OCP4. So in that case, the parameter will be marked as false. So that's pretty much it for now on the CPMA execution itself. What we can look at now is how in an OCP version 4, we have here version 4.1 installed, and we could just use one of the manifests and inject that into that cluster. So first of all, I'm going to check for quota, well actually it's cluster resource quota, There is no cluster quota defined on this OCP4, and we add one in OCP3. So as a day 2 operation example, we are going to create one of the generated manifest. So we just create and provide the path for the file. Oops. So now if we check our cluster resource quota, we can see that there we go, the cluster resource quota has been created from the generated manifest from the CPMA tool. And this is it. Thank you very much for your attention.